at dilations and reflections of periodic functions. So taking a look at dilations, remember that simply means stretches and compressions. So we're going to take a look at vertical stretches and compressions, horizontal stretches and compressions, and also reflections. So we're going to be talking about, first of all, that A value out front of sine theta. So y equals A sine theta. And the property that is affected by that is going to be our amplitude. So we are going to be changing our amplitude. Remember, for our base function of y equals sine theta or y equals cos theta, our amplitude is 1. And remember, amplitude is measured as our max minus our minimum divided by 2, which also is basically half the height of our graph. So stretching or compressing our graph is going to change that amplitude. And the amplitude is just seen as that A value out front. And because amplitude is measured as a height or a measurement, it cannot be a negative. The negative is the reflection. The stretch or the compression is always talked about as a positive value for our amplitude. So if we're going to graph y equals 2 sine theta, we know that this is going to be a vertical stretch by a factor of 2. And what that means is our key points, theta is going to stay the same, but we're going to multiply all of our y values. So what that means is we're going to have a max of 2, and we're going to have a minimum of negative 2. So when we're graphing our y-axis, we're going to keep that in mind. We have no vertical shift or horizontal shift. So we know that we only have to go up to 2 and down to negative 2 on our y-axis. Now, our period is still going to be 360 or 2 pi, depending how we're measuring that. And we're going to do a couple of each type just to show how we can do it in either measurement. Now our amplitude, as we talked about, is going to be 2. Again, a stretch is also going to stretch that amplitude. So on our theta axis, we're not told to graph 1 cycle, 2 cycles, anything. So we're going to actually graph 2, one in the positive side of theta, one in the negative side of theta. And for our key points, we know y equals sine theta starts at 0, 0. We also know we need to go 360 for 1 full cycle. So we're going to go every 4 blocks is 90 degrees. And again, remember, we could also label these as pi over 2, pi, 3 pi over 2, and 2 pi. And on the negative side, same thing. And again, starting with our key points, the only difference between our base graph and this graph is that when we go up to our max, we're going up to 2, back to the middle, down to negative 2, and back to 0. And going the opposite direction for our negative pattern. And then we draw a nice smooth curve between our points. And as always, we make sure that we label with our equation. Next one, now we have y equals negative 2 sine theta. So theta again is not going to change, but we're going to multiply our y values by negative 2. And again, we could go with our key points, 0, 0, 90, and 1, 180 and 0, 270 and -1, and 360 and back to 0. Okay, so we could change those points. We can also think about how our graph is changed. Again, now this one we're going to graph in radians just to see how this goes. Our y-axis, we're still going to have a maximum of 2 and a minimum of -2, and our amplitude is still going to be 2. Remember the positive value of that a value out front. Now, our y-axis is going to be labeled exactly the same. Our x-axis, because we're using radians, but we can still use every 4 blocks, is pi over 2. Because remember, 360 is equal to 2 pi. And again, key points, thinking about 0, 0, normally we would go to pi over 2 and 2, but because it's a reflection, we're going to go to pi over 2 and -2. So it's going to open down rather than up because it's a reflection in the theta axis. So back to 0, up to the max, back to the middle, and then the opposite direction when we go the other way. Again, key points happening every pi over 2. And again, drawing our nice smooth curve and labeling our graph. Okay, so again, we can use our key points and adjust multiplying our y values by -2, or we can think about how it changes our original graph, or actually move our points as well if we wanted to use our base graph of y equals 2 sine theta. Now, if we have a k value out front of theta, which of our properties is affected this time? Well, this is going to be a horizontal stretch or reflection. So this is going to affect our period. Now, graphing y equals sine 2 theta. Remember, anything with theta does the opposite of what it appears to, just like any other function. So we're going to have half of theta, and our y value is going to stay the same. Our y's aren't affected. So because we're going to have half of theta, we're going to have half of 360, which means our period is only going to be 180 degrees. Or if we're talking radians, we would have half of 2 pi, which equals pi. Our y-axis, again, no stretch or compression vertically, so we are going to have a maximum of 1, minimum of -1, and our amplitude is not changed. So graphing, we're going to have, we only have to go up to 1 and down to -1. So again, just stretching out our graph a little bit. We're going to make every 6 blocks, 5 or 6 blocks, depending how you want to graph this. And because we're only going 180, our key points were every 90 degrees. Well, again, we're going to multiply that by a half, which means our key points are going to happen every 45 degrees. So now we're going to just change our scaling on our grid. So we're going to have 45, 90, 135, and 180. And we can plot this again, just like we did before, but our key points are now every 45. There's no stretch vertically or compression or translations, no reflection. So we're going to go from our middle of our graph to the max, to the middle, to the minimum, back to the middle, and again, doing our negative cycle, we're going to go the other way. And again, trying to draw a nice smooth curve. Arrows on the end, and we're going to label our graph. Now, you'll notice that this looks exactly like the last two that we've graphed, but we have to pay attention that the scale is different. And when we have to come up with equations, that's what we need to pay attention to, and we'll get to that. Next one, we want to graph y equals sine 1/2 theta. So again, opposite, 1 over k, 1 over 1/2, or 2. So we're going to multiply our theta values by 2, and our y value is not affected. So here, because we're multiplying our theta by 2, and this time we're going to graph in radians. So our period is now going to be 4 pi. Our max is still 1, our min is -1, and our amplitude is 1. And if we're talking about our key points that we're going to graph, we're going to multiply 90 by 2, so our key points are going to happen every 180. We're going to do this one in radians. So if our key points were pi over 2, we're going to multiply that by 2, and our key points are going to happen every pi. And again, that makes it easy. We're going to go pi, 2 pi, 3 pi, 4 pi. So again, labeling. We just need to go up to 1, down to -1, and every 4 blocks now we're going to have pi, and remember 4 pi is 2 rotations, which is in degrees 720. And thinking about our key points, we start at 0, 0. There's no reflection. So we go to our max at pi, back to the middle at 2 pi, down to the minimum at 3 pi, back to the middle at 4 pi, and opposite direction on the other side. And we draw our nice smooth curve, arrows on the ends, and label our graph. Now, example number 5, we want to graph one cycle. We're going to state the period, amplitude, domain, and range of that one cycle. So y equals -3 cos x. So first we need to recognize, now we're going to be using y equals cos x as our base graph. And again, remember x and theta are interchangeable. And -3 out front of cos means we're going to have a stretch. We're also going to have a reflection around the x-axis. There is nothing inside with x to change our period. So this one, again, we're going to graph in degrees. So our period is going to be 360. Our amplitude is 3. The A value out front, the positive value of the A out front. But we're also going to note it is a reflection in the x-axis. Now, our domain, if we're only going to graph one cycle, then we're going to state our domain is x such that x is greater than or equal to 0, but smaller than or equal to 360. And as long as that's the case, it can be anything in between. It is a continuous line. Our range, we're going to have our y such that y is greater than or equal to -3, but smaller than or equal to +3, and can be any real number in between. So thinking about scaling our grid, we are going to need to go up to 3 and down to -3. And we only need to do one cycle, so we only really need to use the positive. So we could have moved our y-axis over here and drawn it somewhere over here to create our one cycle. Doesn't really matter. And we need to go to 360. So we're going to go 90 every 4 blocks. And those are still our key points. We still want to make sure we have our graph labeled. So we still make sure we have our negative values in there as well. And remembering that we are doing cosine. Now, normally cosine starts at our maximum of 1, which would mean that it would stretch to 3, but we have to remember that it's also been reflected. So if we want to draw our graph of y equals 3 cos x, we can do that and then change it. So if we do that, starting at our max, to the middle, to the min, to the middle, back to the max. That's our graph of y equals 3 cos x. Now, if we want to reflect it, that means we're going down here, up to the middle, up to the max, back to the middle, and back to the minimum. So reflected, we now have our graph of y equals -3 cos x. Okay, so we can also do it in shifts if that makes it easier. Next one, we have y equals 1/4 theta. So we are now, this one we're going to do in radians again. So if our period is normally 2 pi, remember 1/4 means we're going to have a horizontal stretch by 4, which means we're going to have a period of 8 pi. Amplitude is still 1. Our domain in this case then, when we think about our x values, x is going to be greater than or equal to 0, but smaller than or equal to 8 pi. And can be any real number. Our range is going to stay our usual base range, -1 to +1, and can be any real number in between. Now, for our key points, so remember we talked about key points happening in radians, pi over 2, but it's a stretch of 4, which means we get 4 pi over 2, which is 2 pi. And now, again, we can draw our y-axis over here. We're going to change our y-axis over here so that we're going to spread out our information a little bit better. And this is easier to do if you're starting with a fresh, clean grid. So key points are going to happen 2 pi. So we can make 2 pi as far as we want. For our y-axis, we know we're only going to go up to 1, down to -1. And we're going to make 2 pi every 6 blocks because we've got lots of space here. Okay, and key points, middle, 2 pi and 1 are our max, middle at 4 pi, minimum at 6 pi, and back to the middle at 8 pi. And there's our graph of y equals sine 1/4 theta. Okay, and part C, here we are graphing y equals 2 sine -3x. So again, thinking closely about what we have here, our period is affected by that value in here. So, and let's go degrees this time. So 360 divided by 3, because this is going to be a horizontal compression by a factor of 3. So our period's going to be 120 degrees. Our amplitude is 2. Our value out front, we have a vertical stretch of 2. Our domain for one cycle then is going to be x, such that x is greater than or equal to 0, but less than 120. Our range is going to be greater than or equal to -2, smaller than or equal to +2. And if we think about our key points, 90 divided by 3, again compressed by a factor of 3, means every 30 degrees we are going to have a key point. Again, we can move our y-axis over if we want, we don't have to. We know we need to go up to 2, down to -2, and we know those points are going to go every 30, so we can make every block on here worth 10 degrees, meaning every third one is 30 degrees. We could also spread it out further. Now, the one thing we also have to watch here is that we have a reflection in the y-axis. So we're actually going to be going the opposite direction. So we're going to have our cycle in the negative for x. So if we want to think about our base graph first of all, so y equals 2 sine 3x has our key points already keyed off, 30 degrees each key point. We're going to go up to our maximum. So right now we're just ignoring this reflection to get sort of a base graph and see how it's going to change. So this is our graph of y equals 2 sine 3x. Well, now reflection in the y-axis, because our y values are going to change, now this point moves over to the other side. And we notice as well that from here, we're following the same pattern, max, middle, min, middle, just the opposite direction. So instead of going to the right, we're going to the left because it's a reflection in the y-axis. So this is our graph of y equals 2 sine negative 3x. And don't forget, guys, when you are doing these graphs, you can always check your solutions on decimals to make sure that you graphed it correctly. Try to avoid going straight to decimals. Try it first, and then you can check and make sure you've done it correctly. Finally, in general, we just want to state that when we have y equals a sine k theta, or y equals a cos k theta, a is our amplitude. It also tells us whether it's a stretch. So if a is greater than 1, and again, thinking about our absolute values, our positive values, if it's greater than positive value, absolute value is greater than 1, then we have a stretch vertically. If a, or the absolute value of a, is less than 1, then it's a compression vertically and changes our amplitude. For our k value gives us our period. And remember, if it's k, it's changed by 1 over k. If it's 1 over k, it's changed by k. Or it is 360 over k in degrees. So if k is, and again, talking about our absolute value, because the negative is just a reflection, if the absolute value of k is greater than 1, it's compressed horizontally. And if k is less than 1, it is stretched horizontally. And sorry guys, some of these get a little messy. Hopefully you can read that. Okay, so again, just like any other function, these values do the exact same